So welcome to ASMPT here at Productronica. I'm delighted to be joined by Kenneth Coe, who actually runs the semi side of the business. So welcome, Kenneth. Nice to see you.
Hi, Trevor. Nice to see you too.
Okay.
I don't really run the semi side of the business, but I take care of the global marketing for the semi solutions of ASMPT.
I see. So you're doing the marketing side of the semi business.
Correct. That's right. That's right.
So you're based out of Singapore, where of course all the back-end packaging equipment is built.
Yeah. ASMPT is headquartered in Singapore, and that's where I'm based.
Yes. Okay. So the theme at the show here this week is empowering the intelligent revolution.
That's right.
So explain that to me. What do you mean by that?
Right. The intelligence revolution. It is happening all around us, right? You take up your phone. Who could you be talking to? Not your mom, not your sister, but maybe it's ChatGPT, the AI.
Yeah.
And when you're driving, today we have autonomous vehicles that's driving you around everywhere, and this is what the world is become.
Yeah.
Where our lives are being augmented by all the intelligence around us in the devices and all that, and so this is what the intelligence revolution is. The whole world is becoming more intelligent,
Right.
because we have more intelligent devices, and our lives are becoming more convenient and easier.
Okay.
Right.
Okay. So a lot of that, of course, is driven by AI.
Correct. That's right.
And the next step forward from that, of course, is hyperconnectivity. Going from AI into agentic AI and reasoning and that type of thing.
Correct.
So how do you think that's going to fit into the ASMPT semi solutions?
Right. So when we talk about the intelligence revolution, as you mentioned correctly, there's AI, and we talk about just now the autonomous driving, which is we talk about what we call smart mobility, and then the other part that you mentioned just now, hyperconnectivity. What is that? Hyperconnectivity is where we talk about data transmissions, because all these AI and things happening around us actually is collecting data, sending data somewhere to be analyzed, and then it's coming back to us again. So hyperconnectivity means that everything is connected.
Yes.
And it needs to be connected reliably and quickly.
Right.
So that we get instantaneous answers when we ask the AI. Yeah. So that's hyperconnectivity.
Okay, I get it. So the other dimension to this, though, Kenneth, is that a lot of this stuff is going through data centers.
Correct.
And data centers, of course, are known famously for consuming a lot of energy.
Yes.
And a lot of these systems run very hot. Some of the chips or parts of the chips run extremely hot.
That's
They're using things like liquid cooling to cool them down and keep the temperatures down.
That's right.
That in itself, another solution that's starting to emerge more strongly, though, is optics.
Yes.
And using photonics.
Correct.
To basically give the signals, because you get faster transmission signals using photonics, and of course you don't get the heat issues that are associated with it.
That's right.
So how do you see that folding into what you're doing at ASMPT?
At ASMPT, as we mentioned, we are empowering the intelligence revolution. So we have solutions that actually help our customers or the developers and manufacturers of AI, of hyperconnectivity, of smart mobility, of data centers to be more efficient, to be more advanced. As you mentioned correctly, now there's a mass amount of data to be transmitted, and optoelectronics and photonics is the one of the way to go. Other than heat, of course, is the speed of transmission and the volume of data. And in order for this data to be transmitted reliably, efficiently, we are going into the optics, optoelectronics, and ASMPT have the solutions that help our customers actually develop or create so-called, for example, we say co-packaged optics, where we bring the electronics and the optics closer together, reduce the distance between the chip and the so-called the data the transmission or receiving to make the whole ecosystem much faster and more reliable.
Right. Okay. So let's take a look now at some of the machines that you've actually got here that are going to help drive some of this technology for tomorrow.
Yeah.
You've got the MEGA system here, which is known for flexibility.
Yes.
And maybe you can talk to me a little bit more about some of the features that are built into the MEGA system.
Right. MEGA is we have here at this show this time round is what we have the multi-chip module die bonder. Yeah.
Okay.
So it is flexible, as you mentioned, because it can handle different wafers to bring different chips onto the what we want to mount at the end of the day, right? To make the bigger chip or to bring RF modules, chips, and other components together to make the integrated chip. for data communication.
So can it handle different sizes of wafer? That
Yes, yes, it can. Yeah. All right. We have the usual size up to 12 inches and all this. It's all possible.
Okay.
Yeah,
Okay.
that's right.
Okay. And it brings them in and it builds them up into stacked die and things like that.
Yes, yes, yes.
Yeah.
Yeah.
And helps with the bonding. Okay. Excellent. And so what sort of bonding is it doing? Is it doing gold wire bonding? Ball
No,
bonding?
this is not wire bonding. This is a die bonder.
Die bonding.
Die
Sorry,
bonding,
I'm so
right.
sorry.
Die bonding. Yes. So we picked from the wafer, or we can pick from tape, or we can pick from basically different ways that components can be fed into the machine. And then we picked it, and then we can place it onto a substrate, a panel, or PCB.
I get it.
depending.
I get it. Excellent. Okay, good. And the other machine you've got here is the AMICRA. This is the one that's standing behind me.
Yeah, that's right.
So maybe this does ultra high precision placement of packages and assemblies. So
Correct.
maybe you can give us some of the key features of the AMICRA system.
Correct. So when we go into optoelectronics, ultra precision is very important. So that you need to align, make sure that the lens, the opto components, and the electronic components are aligned properly, so that you get all the data transmission.
That's the hardest job.
Right,
Yeah.
right. So the AMICRA Nano, we are featuring 0.2 microns accuracy. So it's a sub-micron, actually 200 nanometer accuracy machine. Yeah. So this is well suited for the co-packaged optics assemblies.
Excellent, excellent,
yes.
excellent. So, I mean, the AMICRA obviously solves a number of problems for customers. So, can you go through some of the key areas that it solves for manufacturers putting together the photonic packages?
Right. As we mentioned just now, to put together the photonics package, high accuracy is required. And so this is what the machine is built for, right? Very sturdy base, highly so-called our technology where we can look at the chip and the substrate at the same time. So to ensure the alignment is truly accurate. And this is where we achieve our 200 nanometers accuracy. And this is we are the only one that can do it.
You're the only people that can do it. Well, that makes you fairly unique in the industry.
Yeah.
And certainly a little bit ahead of the game because the photonics is just starting to open up now.
Right.
But it's certainly going to be a major market for the future.
I think at the present moment we are the most accurate machine in the market. So we are supporting all these guys, all the developers and manufacturers going into photonics and optoelectronics.
Excellent, excellent, great. Well, thank you very much, Kenneth, for sort of giving us an update on these machines, and we wish you every success with them going forward.
Thank you very much, and thank you for coming to our booth.
Thank you.